In this video, we're going to take a look at greatest common factor. To figure out what a greatest common factor is, we're usually given two numbers. So like in this case, let's pretend we're given 8 and 12. If I want to know what the greatest common factor, often abbreviated as GCF, is, one method is to take the two numbers, 8 and 12, and list the factors. So the factors of 8 are 1, 2, 4, and 8. Remember, a factor is a number which divides evenly into 8. So 8 is divisible by 1, 8 is divisible by 2, 8 is divisible by 4, 8 is divisible by 8. For 12, the factors would be 1, 2, 3, 4, 6, and 12. Looking at these two lists, the number which is the largest that they have in common would be 4. So I would say my greatest common factor, the greatest common factor of 8 and 12 is 4. So the method 1 that we covered is a method called listing. You're going to list what are the factors and then decide which one's the largest. A second method for finding the GCF deals with using the division ladders, which we covered last section when we looked at finding the prime factorization of a number. But we had to use prime numbers. In this section, we're going to use division ladders a little bit differently. If I give you the 8 and the 12 again, I'm still going to list them side by side. I am going to form sort of the division ladder now, but I can write any number outside. So 8 and 12, for example, I know are both divisible by 2. That's going to leave me with 4. 8 divided by 2 is 4. 12 divided by 2 is 6. Now I take a look at the 4 and the 6, and I say, do they have anything else in common? They're both divisible by 2. So 4 divided by 2 is 2. 6 divided by 2 is going to be 3. So the numbers that are listed here, if I multiply them together, give me my GCF of 4. Now I said you didn't necessarily need to use a prime number because if outside 8 and 12, if I notice that they're both divisible by 4 right away, I can just put the 4 outside, leaves me with 2 and 3. 8 divided by 4 is 2, 12 divided by 4 is 3. There's nothing else in common between the 2 and the 3, therefore 4 is my GCF. So my GCF is found by is the number on the outside here, on the left side here, or is what I get when I multiply the numbers. This again, because the division ladders is probably my favorite way of solving for GCF. Because sometimes listing is very easy to miss one, and then with the division ladders, it's just a little bit more obvious. So let's say I gave you the values of 80, and I gave you 96. Now you might not know where else to start. But you might say, oh, you know what? I know that they are both divisible by 2. So 80 divided by 2 is 40. 96 divided by 2 would be 48. And then you might look at this and say, oh, 40 and 48. Well, what can they both be divided by? Well, I know that they are both divisible by 8. Okay, so I get 5 and I get 6. 5 and 6 have nothing else in common. So 8 times 2 would give me my GCF of 16. If you were using the listing technique for this, you would have been listing a lot of factors, and it wouldn't have been that easy to do. Where with the division ladders, once you begin to find one common factor, you'll end up with smaller numbers. It becomes a little bit easier, and then you can just multiply to get what the GCF is. So it's a technique that I think is fairly helpful. The last method that I'm going to show you, just because it's mentioned in the book, deals with using factor trees. And more importantly, the prime factorization. Okay. If I take the 8 and the 12 again, I'm going to do a factor tree for each of these. 8 would be 4 times 2. The 4 I can break down into 2 times 2. The 12, I might begin with 3 times 4. 3 is prime. The 4 breaks down into 2 times 2. What I'm going to do with the with this method is I'm going to write both of these out with the prime factorization, and I'm going to choose not to use exponents because it's actually easier without exponents. So 12 would equal 2 times 2 times 3. What we're going to do with this method is we circle what are the factors that they have in common. So there's a 2 in both of those. There's a 2 in both of those. So I would end up with 2 times 2 would equal 4, which was the GCF. Okay. This method isn't really that bad. I like the way the division ladders portray the information a little bit better, but if you are more comfortable using a factor tree and finding what the prime factorization is, this isn't a bad method. It's a good method. It gets you to the answer, but you have to keep in mind this would count as a 2, this would count as a 2, so they count as separate 2's. You're looking for what are the factor pairs that are common to both. The 2 and the 3, okay, there's nothing else here to pair it up. So that's where I get my answer of 4.